Okay, we are moving on to the next section here. I've got derivative extras as the heading for this one. So this is after the section 2 or section 2A, kind of going through some extra problems that came from AP Calculus exams as well. So let's go through some of these. First one there, number 1, find equation of the tangent line at a particular point. We know the concept here, where you just have to find the first derivative, plug in that point. And so the first derivative of tangent theta is going to be secant squared theta. All right, getting a little sloppy there, but we want f prime, or the first derivative, at pi over 4. So you have secant squared pi over 4. You don't often see that, but we should be able to manipulate this. Secant squared is the reciprocal of cosine, so we have to figure out cosine of pi over 4. Okay, cosine of pi over 4 is root 2 over 2. And then if you take that cosine pi over 4, we're going to flip that over. So secant pi over 4 would be 2 over root 2. And if we multiply that by root 2 over root 2, you get 2 root 2 over 2. 2's cancel. So we have root 2 is secant. And if you square that, then you'll get this is equal to 2. Okay, so all that comes out with 2. That becomes your slope. That is your point, so that is your slope. Put those together, you should end up with C as a final answer. Kind of work through the logistics there, make sure you end up with that, but that was the calculus end of it. And moving on to number 2. The nth derivative of y is denoted by y to the nth power. Okay, so what does that mean? Okay, so y, we want the 17th derivative is what they're trying to communicate there. Okay, kind of weird, but that'll happen in math where you get these huge derivatives as you go through various semesters of calculus, but y, the 17th derivative of y is what we're trying to figure out there. And so we're hoping there's a shortcut here, and you'll see there is a little pattern that comes out. Your first derivative is, so you start with minus sign, so the first derivative is minus cosine. Second derivative is sine x, yes. Third derivative, actually I guess I should write this, they're denoting it that way, so we can do that, cosine x. The fourth derivative is, first derivative, well, it's back up to minus sine, up there. And then this is your fifth derivative, is going to be cosine. Your sixth derivative is sine, your seventh derivative. Okay, so you see this pattern of 4 emerging. Where is the 17th derivative going to fit on that scale, on that system there? So 8, 4, 8, 12, 16 is going to be down here at the bottom. So that's 12, that's 16. So 17 is going to be back up here at the top, which is equivalent to the first derivative. So that's B is the way I would end up doing that problem. 3, first derivative, I've got that as an answer of A. And 4, I've got that as an answer of 6. And we're just going to kind of keep moving through here. If we go next slide, we're on the next page of derivatives extra, starting with number 5. And a particle moves along an axis. We've got dy dt, related rates with respect to t is what's happening here. Okay, so I've got this original function. I'm just going to kind of write this over. Y equals 3x squared plus 4 to the negative 2 I'm going to find the first derivative with respect to t. So I'm going to go dy dt equals negative 6 times what's inside, knock the power down 1, times the derivative of what's inside. Okay, so this is your dy dt. Okay, so we have that as 6. So 6 equals, if we can make sense of this, we've got negative 12x up on top. Yes. And then x squared plus 4 to the third power on the bottom. And then, I'm sorry, we forgot one system here. One derivative we forgot. Back here we're taking with respect to t, so the first derivative of x squared plus 4 is 2x dx dt. Okay, so there should be a dx dt back here. Okay, because I was almost going to run out of variables. So I'm going to plug in 2 for x. Plugging in 2 for x. That would be 2 squared is 4 plus 4 is 8. How about we do that again? You can always double check my work here. And ending up with 32 as an answer, or negative 32 as an answer. Okay, so if you solve that for dx dt, you should get negative 32. So if you take a look at number 6, which of the following will calculate the derivative. So this is just asking what is the first derivative by definition. There's some definition that we learned. And we should zero in. Just take your time here. You know, we have to have limits. That's a common mistake. We have to have limits in there somehow. And so it's going to end up being D as our one that matches our definition. Okay, and number 7, use a graphing calculator. I don't know if you need to use a graphing calculator. Excuse me. You're trying to find the x values where f is not differentiable. Okay, a lot of times that happens with that fractional exponent. Okay, but you can just find the first derivative and run from there. You'll end up with this negative 3. So that's going to be 0 to a fractional exponent, which will cause havoc down the road there. But that's where that ends up. If you go ahead and take the first derivative and go from there. And let's keep moving on to the next page. So we're on to number 8 here in the derivative extras sheet. Use a graphing calculator to graph its derivative. And I don't know again that you really need to use the graphing calculator, but you should find that it has a horizontal tangent line. See? Number 9, you've seen this problem, I believe. Graph at the right represents the graph of the derivative of which of the following. Okay, and so this is the derivative. Okay, and so if you zero in on a couple of things here, I guess I would zero in on that point right there. So we know that it's important here that this function goes from negative numbers, negative slope, to 0 slope, to positive numbers. So it's a parabola. Okay, so we're expecting a parabola. Another way of kind of looking at it, another viewpoint, if you will, would be that this original graph here is the line y equals, let's see, it goes, y-intercept is -2, and it goes up 1, 2, 3, 4, for every one it goes over, y equals 4x minus 2. So we're looking for the first derivative of any of these that give you 4x minus 2, and you don't. It's got to be something like the original function would have to be 2x squared minus 2x, something like that, plus some number. Okay, and also I should have designated, so this equation is y equals 4x minus 2. That is the first derivative. Just kind of getting that habit. That was the derivative. We want to denote it properly. But anyway, the answer is not there. Okay, this would have been a viable answer, but that was not possible. 10. Sorry. And number 10, if you look at that, find the value of the first derivative at the function, or first derivative of the function at a particular point. You should be able to do that. I'm feeling good about that. That's a nice solid problem. Take your time for that. That's just your low d high minus high d low all over low squared. You're feeling confident. That doesn't mean speed up. It means take your time. Make sure you definitely get that problem correct. Okay, so that is the end of the derivative extras.